Thank you. Cool, thanks for being here. It's great to be back in Amsterdam, in this lovely, lovely place. Appreciate you all being in this room. Today I want to talk about some very important topics that I think, as creators, we are really responsible for being involved with. And I want to look at it through kind of like a personal project of mine that I've been involved in. So my name's Joe. I'm primarily an Android engineer at a company called Buffer. We deal with social media scheduling tools. In my free time, I'm also a charity for, I work for a charity called Sea Shepherd. I do some volunteering in the UK for them. And if you haven't heard of them, they're definitely worth checking out. And I also like diving into numerous technologies and learning new things. And that's kind of what this talk is about. My Twitter handle's in the top right-hand corner there on each slide, so if you want to tweet any pictures, comments, or some funny attempts at the captioning at the bottom there, then feel free to do so. But first, I want to take a step back from technology and from all the technical content that we take in. And I think unintentionally, it's easy for us to become isolated from others around us. So life is busy. And it's easy for us to get caught up in our own things and our own little bubbles and often forget or not even think about the things that we are doing and how they might look for someone else. For example, maybe how you got to this conference. As say if you were blind, deaf, maybe physically disabled, how would that have looked? How would you have safely found your way to the public transport station? Cross that busy road that's a couple of blocks away. And even what you did on that journey would likely have looked very different. And once people manage to do these things, we know that there may be hurdles for some people, and these things can look very different. And with that said, disabilities themselves aren't always visible at a first glance, or even at all. It's a known fact in the UK that around 50% of the population see disabilities as a physical impairment. In the UK, I've often heard people making comments at people parked in disabled parking bays who don't at first glance look like they have a disability. And people make comments like, oh, why are they parked there? They don't look like they've got anything wrong with them. And it's those kind of impressions that can sort of, contribute even more to that aspect of us not being aware of things that people might be involved with. So I'm going to take a quick look at some disabilities that can happen and people can be faced with. Worldwide, we have about 15% of the population that have some form of disability. And that's about 1 billion people across the globe. Whilst that's kind of vague, there are a huge range of different disabilities that people can experience. And as we go throughout the years and through our lives, this is only bound to increase in a linear fashion. As a species, we are living longer. We're living to older ages. And a lot of disabilities are age-linked, so it's more likely over time that we're going to see more disabilities appear throughout more people. And disabilities can also be accident-linked. We often hear of people maybe they've gradually gone blind over their lifetime, or they've been involved in some form of accident that's taken away their ability to function in some way. I was watching a video a couple of days ago from a Google engineer who's worked on making Google Maps accessible for wheelchair users. And as of a couple of years ago, he was, perfectly able to walk fine without an issue. And he'd take his normal walk to work every day through Central Park. And one random day, he was doing that exact same route he'd always taken for the last 6 years of his life, walking to his job. And part of a tree broke and fell on his head. And that caused brain damage that actually removed his ability to walk. And he was, involved in that everyday task that he'd always done, and all of a sudden he's lost his ability to walk. And that goes to show that some of these things can just happen and change, and it can really change the course of people's lives. And with that in mind, with that comment, only 17% of people overall in the UK are actually born with their disabilities. So whilst that story that I just mentioned of that person losing the ability to walk, 83% of people with disabilities experience things like that, whether it's things that are similar, things that are the same, or something along the same kind of case. So it's far more common in that case to get a disability as you go on through your life. And I'm not trying to scaremonger people into getting more involved in disabilities, but that's just a known fact. And with disabilities themselves, there's a lot of crossover that can happen. Maybe if someone faces hurdles from being blind or being physically impaired, there's a lot of crossover in the things that can aid those people in their disabilities. So I think that's why it helps to be aware of the different things that can happen. We can start off with physical conditions. So these are things such as people being in wheelchairs, maybe people have limb injuries or have conditions such as cerebral palsy. And for these users, we can see a number of different physical disabilities involved and a number of different hurdles that people can face. So for example, in the UK, we have over 1 million people who are wheelchair users. And as I just mentioned about the Google Maps wheelchair edition that was introduced, I think it was last year, it went into beta. For the amount of people who are in wheelchairs, that is an incredibly late feature release that was probably heavily needed before then. We also have people, 6,000 people in the UK who have some form of restricted growth. Something that's often overlooked, there's two kinds of restricted growth, and this is proportionate short stature growth and also disproportionate short stature. So disproportionate is where people can have really short limbs, like to the point where they're almost non-existent. So someone's arm may be up, like for example, start from end here, and this arm might be perfectly normal length. And this is something that, I've never really thought about, but some of us are privileged enough to have 3 meals a day, and we go personally, I just eat my food and just stuff it down my face, and I enjoy the food itself, and I don't even think about the thing that I'm doing at that time. But for someone with restricted growth, even such a thing as like picking up your cutlery and being able to maneuver and eat that food can look incredibly different for what to us seems like such a simple and such a normal task. We also have cognitive conditions, and this is something that I'd never really thought about until I started looking into it more. And this is a hugely popular thing in the UK. For example, we can see 1.5 million people in the UK have some form of learning disability. And this can be something such as dyslexia, which is hugely common. For example, ADHD even. And ADHD is something that there's a kind of a presumption that it's only involved with kids, but actually 60% of adults who had ADHD whilst they're in their childhood carry those symptoms through to their adulthood. So those things still affect people throughout their lives. And autism is an interesting one. So 1% of people worldwide, I can't remember what exactly number that is. Oh, it's on the slide, isn't it? So 70 million people worldwide. So that's something I've never really thought about. Like I've been aware of autism, but I've never thought how it could affect the things in the products that we use. If you get time to check out that link, I know it's kind of long, but it's a really interesting study from someone who worked at Google over the summer, and they did a design course and with a group of people who have autism. And there were some really interesting learnings from that study, and one of them that really stood out to me was the use of ad blockers to restrict the content that is shown on websites. So all of these users use an ad blocker to strip the left-hand, right-hand sides of Facebook. Because Facebook's there's a lot going on, there's all the menus and all the content on either side of the main news feed. So those users use the ad blockers to hide those things because they couldn't use the website because it was too distracting for them. They couldn't focus on the content. And those users don't even use the mobile app because you can't do that on the mobile app. You can't get an ad blocker to restrict that content. So not focusing on Facebook there, but that is a huge loss out of that amount of people worldwide. That's a huge loss of users on their mobile apps because a lot of those users are going to likely experience those same symptoms. Hearing loss is another thing that's a huge issue at the moment. 466 million people worldwide who have some form of hearing loss. Hearing loss is not a simple condition to look at, but out of these numbers, about 35 million of them are children and the rest of them are adults. But it's predicted that by 2050, there's going to be around 900 million people who have some form of disabling hearing loss. So that's hearing loss that will cause a hurdle in you doing something in your day-to-day tasks. In hearing loss, we have, so 2 types of main hearing loss. So we have permanent damage and temporary damage. So permanent is known as sensorineural hearing loss, which is when you have damage that's either caused by the nerves in your ear or by the hair follicles in your ear, and that's permanent damage, and that's not something that surgery can fix or not something that medicine can fix. You can have hearing aids, but it's kind of like a just a fix, not a permanent fix for what's the damage is caused there. And we also have conductive hearing loss. And conductive hearing loss is more temporary and more something that's caused by like blockage or some form of temporary disease that can be cleared up. And that sounds more like, I don't know, I'm not expecting you to do this now, but if you stick your fingers in your ear and you start talking and it sounds really cloudy, that's what conductive hearing loss sounds like. It's not permanent, but it does cause quite a hurdle in day-to-day things when it comes to the hearing. Another big one is vision impairment, and that's a big one worldwide with 1.3 billion people. And again, it's a complicated disability because people who have visual impairment can still see. There's some people who are blind, but it's predicted about 36 million people out of that number are completely blind and have no vision at all. And we also have another number of 826 million, which is more things like cataracts, glaucoma, retinitis pigmentosa, so things that cause blockage in your eyes, but you still have some of your vision. So out of that number, 826 million people still have visionary difficulties when it comes to their eyesight. And when it comes to those visionary difficulties, this is what some of these can look like. Cause, glaucoma, cataracts, like I mentioned. It's likely that people in here either know someone or have some family member or grandmother or granddad who has one of these conditions or has had one of these conditions in their lifetime. It's very likely, as some of these are very common. But as you can see here, some of these cause quite, blockage in your eyesight, especially ones that block like the central vision, like the diabetic retinopathy, and also retinitis pigmentosa, like really blocking out that central vision and the things that those people can see. And I want to hone in on this one on the bottom right-hand side there, retinitis pigmentosa. It's a bit of a mouthful, but as we can see here, this condition can really take away quite a lot of someone's vision. And this isn't even like a bad case of it. Some people can have even a lot less vision than this. And this is actually a condition that runs in my mother's side of the family. It basically causes eye cells to die off gradually. So you get black spots in your vision. Those spots can be random, like completely separated, or they can clump together to form larger black areas, like that shown on the screen. My grandmother also had this condition also, and her vision ended up being like the size of a pinprick, and she literally could not see anything in her central vision. So I always knew about this condition, but I didn't really know the severity of it. Maybe I was being naive there, but there was a few events that sort of got me thinking about it. So I think I was 22 at the time, and my mum, she had like a couple of spots in the corner of her eye, and she didn't really cause her any problems. And I think there was one time where she got a spot in her central vision. It was literally just in the side of her central vision. And in the UK, if you have any obstacles in your central vision, you can't drive at all. So that doesn't sound like a huge thing, like, oh, well, just get public transport. But for not everyone's privileged to be able to, get taxis or be in a place where they can get public transport or just pop to the shops. For someone, whilst my mum's quite lucky that we live near her and we can still help her move around, for someone who might live in a remote area or in the middle of nowhere or doesn't have access to those kind of things, that can cause a huge obstacle in even just doing simple things. And another time was when my grandmother was in hospital, and I remember being there with my mum, and we were probably there like 15 or 20 minutes, and my mum had been talking to my grandmother, and I was literally standing right there, and I came up in the conversation, and my nan was like, oh, why didn't you bring Joe with you? And it felt really awkward, and I was like, I've been here for like 20 minutes, like what's going on? And literally, I was literally right in front of her, and she couldn't see me, she didn't even know I was there. And she laughed about it, and we had a little bit of a laugh and stuff to laugh it off. But that was kind of like the turning point for me. I was like, wow, she literally cannot see anything, and I was right there. And it got me thinking more about what other people experience. This condition is actually quite not super common, but a lot of people do have it, and it can progressively get worse throughout your lifetime. So, and it got me thinking more about my life, and I'm kind of lucky and in a privileged position to not have this condition yet. It's got me thinking, what if I did have it? Say if I got it when I was a kid, how would that have affected me? And that got me thinking more about things that I do and how those things might have been affected if I had such a condition. And maybe take a moment to think about this also. Think about outside of work. Let's not think about coding. And think about the things that you like doing, that you enjoy outside of work. And for me, it is guitar. I'm not a great guitarist, but I love playing guitar. It's always been a great way for me to switch off from everyday life, have a form of creative outlet. And when I was at university, I played in a bunch of bands, and that was like really good confidence boost for me, like get out there and just do stuff and have fun. And if I had this retinitis pigmentosa, I kind of started to think, how would that have looked? How easy would it have been for me to learn guitar? Would I have been able to read the guitar tablature? Would I have been able to go online and watch videos and listen to audio format? And I started looking at other disabilities and thought, wow, like any of these conditions would have caused a hurdle for me. Like playing music and learning music hasn't ever really been made that accessible. Like I couldn't really find anything that could make this easier for people. And I'm not saying that people, if they have disabilities, that they can't learn music, that it's not possible. I'm more saying like how could we make things so they could be more accessible and remove any hurdles that could be present. And that's where I came onto the mind of Chord Assist. And Chord Assist was a little project I started playing with to try and make music more accessible and try and make what I enjoy and hopefully be able to share it with others. And what I ended up with was this guitar that, it's only a prototype, and it's got a few little twings here and there, but it's a guitar that allows people who are blind, deaf and mute to be able to learn music and to be able to learn the foundations of playing music and make it more assistive in doing so. And the interesting thing is it is an assistive technology. It's not, whilst I made it for people who have disabilities and whilst I made it to be accessible, if you take away the Braille reader, anyone could use it. Anyone could use this and learn guitar chords. It's kind of like it's open for all. Does anyone in here play guitar? Do you have any guitar players? Cool, I've got a couple, that's good. So if you're familiar with guitar, you may be familiar with guitar chords. If not, the whole kind of like the foundations of learning guitar, and when we start learning guitar, we always start with chords. I remember when I started learning guitar, I found them really boring and I really didn't want to learn them, but they're kind of like the foundations. They're introductory enough to be able to ease you into learning the guitar, as well as making up all the parts of the songs that you're going to learn in future. When we come to learning chords, we either have like visual diagrams like this, which tell us where to put our fingers on the fretboard, or we might have a set of instructions that say this string is open, or this string has your finger on this fret, and to kind of tell us where to put those things. And what the guitar does is essentially takes each of these formats and tells you where to put your fingers. And the guitar is made up of a bunch of different technologies. We have Firebase, we have Google Cloud services, we have Actions on Google, which is like the whole OK Google system, Python, we're all running on a Raspberry Pi, and a bunch of different things come together to make it all work. And a lot of this is outside of the norm for me, like I'm kind of just like an Android person. So this was really nice to learn a bunch of new technologies and try and wedge them all together to get them to work in a way to help others. So I just want to run through how it all works and how everything is tied together. So as I mentioned, we have this Raspberry Pi, and this essentially is the brain of the project. Everything runs on here. If you're not familiar with Raspberry Pi, essentially a small computer, and they cost about £35. I had one sitting in my cupboard for about 5 years that I'd never used because I remember they came out and everyone was like really excited, like, oh, these are a really cool thing. But I know so many people that didn't actually end up doing anything with them because we couldn't think of anything. But finally, I thought of something a few years later and managed to make use of it. So with a guitar, there's two ways to learn the chord, to be able to interact with the guitar. So we can either speak to the guitar and tell it what chord we want to know how to play, or we can select the chord. So there's two reasons for that. So there's basically, if you're able to speak, then you can converse with the guitar. But we also have, I think it's 5% of the global population are mute. So that's where you can't speak. And it's either someone who is born with the inability to speak, or someone who is deaf and stopped conversing with people and just gradually got out of the habit of talking and actually lost the ability to communicate via voice, which sounds really scary. And so for that purpose, I put in the option to also select a chord. So let's focus in on this conversational side of things to begin with. So the conversational side of the guitar is completely powered by actions on Google, and this is essentially the brain of the guitar as it brings everything together. And you can write actions on Google apps in Kotlin, JavaScript, and a range of different things. If you're not familiar with actions on Google's, so as I said before, when we use OK Google, sorry if I've triggered anything, when we say that and we trigger something, like, I don't know, talk to Tesco or talk to Spotify, all of those things are powered by actions on Google. The tool offers an SDK along with some services that abstract some of the complexities of that service. And one of them known is Dialogflow. And that's the service I originally used to create the conversational side of the guitar. And there are several concepts that come into play when building a conversational tool in Dialogflow. The first and the most important is an entity. So an entity is kind of like a data object that can be represented by a number of different things. And an entity, in this case, is a chord, because we have the chord, and that's the core part of the thing of the guitar that we want to be able to learn. And each chord can have a number of different values. So we have the A chord, the C chord, the E chord. So these are all the different possible values of the chords, along with all the different things the user can say to trigger that chord. We also have intents in actions on Google. So these are all the different tasks that the user can trigger. So whilst there's a bunch of things here, we're just going to focus in on this learn chord one, because the user wants to learn a chord, so they're going to trigger this learn chord intent using their voice. And within the intent, you can also define a bunch of different phrases which can be said to launch that intent. So the user can say any of these things, and that will trigger the conversational flow for learning the chord. And each intent can also be linked to an entity. So within an intent, we can say, to be able to satisfy this intent, we need a chord value that's from this chord entity. And the intent can't be fulfilled unless we have that value. So if you say, tell me how to play a chord, Dialogflow will detect that there's no chord there, and it will prompt the user to tell them what chord. But it's also pretty clever. So if you say, tell me how to play the C chord, Dialogflow will detect that there's a chord name there, and it won't prompt the user. It will just pick that chord name out for you. And that's because we've got that clever mapping that Dialogflow does to that entity value. So we have this process. Everything's linked up to Dialogflow. We have the guitar. You can say, tell me how to play the C chord. That will send the conversational words to actions on Google, and that does all the natural language processing for us. We don't have to do anything there. And then Dialogflow app, which is our application, which we have written to handle the chord request, will generate the instructions for the chord and send them back to the guitar. And that application, I don't want to go too much into this, but that application is just something that sits on a hosted service, such as Google Apps or Firebase Functions, something that you can get a webhook URL for. It doesn't matter where it's hosted. This is written in Kotlin. You can write it in JavaScript. Essentially, for each intent, we just need to write a function that will handle that intent. And basically, all this does is generate the instructions for the chord and send it back to Dialogflow. And that fulfills that intent that we have. So as mentioned, the user can request how to play a chord, where we have a microphone on the guitar, and this microphone can be used to converse with. And this microphone is just a USB microphone that plugs straight into the Raspberry Pi that the user can talk to. And in terms of the code, we're just using the Google Cloud to text SDK to capture that. So this is written in Python. As you can see, there's not actually much code to handle that converse with the guitar. We just create the client for the text-to-speech. We call this recognize function, and then the input that's captured will just be converted to text for us. So we can see that there's not much that's needed to handle that conversion. We also have the ability to select chords. So alongside the voice communication, we want to be able to allow the user to select a chord. So using the toggle buttons on the guitar, the user can flick through the available chords, which are pulled in from Firebase, followed by hitting the central button to select a chord to learn. So whilst we have these chords defined up here, these come from Firebase, but I've done this here just for simplicity. The user simply all we do here is we keep track of the selected index and display the chord on the screen. And then, as we can see down the bottom here, this is the core part, we have this same function that was triggered by the voice function. And what I've done here is maybe kind of lazy, but the function before that converted the voice to text, which would say, tell me how to play the da-da chord, all I've done here is hard code this text, take the selected chord, and we trigger exactly the same flow. So from a development perspective, there wasn't much more that was needed here to handle that conversion. Alongside this, we also have a number of different ways that the user can make network requests. So whenever you do a conversation, a network request happens to Dialogflow to handle things. So to get a little bit creative here, because if the user is waiting, we want to let them know that they're waiting for something. So I decided to stick a little vibrating motor next to the Braille reader. This just vibrates when a network request is happening so that the user knows that they're waiting for something. I actually took this idea from something we have in the UK. I don't know if you have them over here, but underneath the traffic lights, if someone is blind or deaf, they can place their hand underneath the traffic light bots, and this little thing spins around when they can cross as a kind of an accessible way of letting them know that they can cross the road safely. So at this point, we've handled the user input, and we sent this off to Dialogflow for processing. But we need to actually handle the response that we get back from Dialogflow. And there's a number of different ways that we display the chords on the screen to the user. So I'm going to take a quick look at how we do each of these. Before that, the user can toggle each of the outputs that's on the guitar. So we have a speaker output, we have a screen output, and we have a Braille output. We put toggles on there that the user can turn each one on and off if they don't need all of the different features that are available. When it comes to that Dialogflow request, we have this detect intent text function that's come up a couple of times from the conversation side of things, and also the buttons. So this isn't much code to handle to be able to communicate with our Dialogflow app. So first, we take the SDK for Dialogflow, and we create this new client. We then create a new session for our conversation using our Dialogflow ID. We use a session ID also just so that Dialogflow knows that this is the same conversation that is happening. We then create the text input object for our request, and this would be the text generated from the chord selection of the spoken word from our user, coupled with the language code for the request. So Dialogflow can handle many different languages, so if you need to support more locales, you can do. We then create the input for our query, and then use our session client to trigger the intent flow. And this will send all of the data that we've previously created from our data to Dialogflow. In terms of handling this response, let's begin by taking a look at the screen, which can be used to display the chord to the user. And there's a couple of steps here, and we first need to download the chord from Firebase functions, and then show the response on the screen to the user. And when it comes to this again, the code doesn't actually consist of too much, thanks to the cloud SDKs. We begin by creating a new storage client and a reference to our storage bucket. Then we retrieve the blob for the file, and then download the file, saving the reference to our local variable and showing it on the screen. Once we are done, we'll simply pass this reference back and display it to the screen to the user. We also have the speaker, and this is where we're going to display the audio for the text response of the chord instructions. Using the Linux's built-in ability to play text in the form of audio, we simply send a command to the command line to trigger this, and the chord instructions are automatically spoken for us. And our last step in the process, which is probably my favorite, is the reading of our chord instructions in a Braille format. So I'm just going to skip past these. I think we're almost over time. So when it comes to the code for the Braille, it's probably a little bit more involved than the rest of the project. But essentially, all we're doing is we have probably a bit long-winded, but it was the easiest way to get it going. We have each possible character in the alphabet mapped to a Braille representation in a binary format. So these how the pins are going to look, as well as any special characters and numbers and so on. When we get the response back from Dialogflow, we pass the whole text string into this function, and all that will do is essentially loop through every character in the string and create a new string with all the different Braille formats for every single character. So that's like a massive long string of all these different binary values for the Braille. Then all we do is loop through each of those Braille representations and set the pins on the guitar so that the Braille pins can pop up and down to read out the chord in a Braille format. I'm not sure if we saw an image for that, but yeah, these pins here, we can see here, they're popping up and down, and that will read those E string open, A string frets, so on, to the user in a Braille format from the guitar. So skipping back to the end, and as a result, we end up with a guitar that allows different users, whether they're blind, whether they're deaf, whether they're mute, to be able to interact with this guitar and learn those foundations, and hopefully giving them the confidence to be able to continue learning the music and the guitar. And all of this process was completely different from my day-to-day work. And I think I'm so confined to creating experiences for the small screen and the desktop and so on. And this was a completely different world. And being out of my little green Android bubble was really opened my eyes to some of these core issues around me. And during my research on disabilities, I came across this phrase, learned helplessness. And it was about 15 years ago, I think, this quote was taken from. And this was from a user who had become disabled in their life, one of those 83%. And they actually said they felt like they had learned to become helpless in the things that they do in their day-to-day roles because the lack of tools and accessibilities for the things that they're used to doing. And as engineers, designers, I think it's our responsibility to discover ways and build solutions in which can make the things we do in our day-to-day lives accessible for everyone. And to end the talk, if I could ask one thing of you all, when you leave here, when you go outside, when you make a coffee, or when you go home and do the things you do, maybe start to think about how those things could look for other people, or look for people who have certain conditions, and how different your life might be if those things could have been involved with you somehow. And that's it. I don't think we've got time for questions, because I think I've gone over. But if you want to come talk to me afterwards about the guitar or learn a bit more about it, I'm happy to talk to people or answer any questions that you may have.
Thank you.
Cool.
That was amazing. Thank you so much, Joe. I can really relate to having relatives with visual impairments too. Next up, we have Chinenye. So we'll do a quick swap over. Thank you.